All right, so let's take a look. We're doing subtracting with fractions again. The only difference is today we're going to go ahead and look at it more of an equation or an algorithm based rather than looking at any of our picture. So let's take a look. So if I want to do subtracting and I want to use just my numbers, I don't want to use any of the pictures because drawing out 12 and ninths, you're getting into something a little more daunting, and some of you don't have the best fine motor skills to do that. Or you might just be very number oriented and it's easier this way. If you're going to do that, then let's write it out the way you would normally write out any subtraction problem. So we write it out 12 and 2/3 minus 3 and 8/9. Now I've got them lined up by place value like I normally would with subtraction, with my ones on top of my ones, and I've lined up my fractions together because obviously those are the part that we're going to be subtracting from each other. Now, I still have the same problem that we consistently have every time. I can't do 2/3 and ninths. I can't compare those and do stuff with them right now because I need them to have a common denominator. So over here on the side, I'm just going to go ahead and turn my 2/3 into ninths. Okay, to get my thirds into ninths, I need to multiply by 3. So doing that on top makes 6/9. So instead of it being 12 and 2/3, what I really want this to be is 6/9. So I'm going to move this over just so that they're on top of each other still. So I'm doing 12 and 6/9 minus 3 and 8/9. Now, if I was doing a subtraction problem like this and my top number here was larger than the bottom number, I'd be done and set. I would say that's it. Go ahead and move on, do your subtraction. That's not the case, okay? So when we look at this, I can't do 6/9 minus 8/9, okay? Because I can't take 8/9 away when I only have 6 of them. So I'm going to borrow like I would with any other type of subtraction. If I don't have what I need here, I go to my neighbor and I borrow one. This is the part that's tricky for a lot of people. So I'm going to borrow 1. So that part's pretty consistent. I took 1 away. Now here's where things get weird. When I take that 1 away, I took 1 unit away. I'm breaking it up into a fraction. Most people want to add 10 right here because that's what we do normally in the base 10 system. When you break 1 apart, it becomes 10 of the next piece. But I don't want to break it into tenths, right? I need more ninths. I'm taking away 8/9. I don't have enough ninths, so I need to take the one that I borrowed away and I'm going to turn it into 9/9 because I need more ninths. So if I add on 9 more ninths, I'm going to add 9 here. This now becomes 15/9. And that's our biggest mistake, is that people always want to just add 10 there. But I'm adding on ninths because that's what I needed, ninths, not tenths. So now I can do some of my subtraction. I have 15/9 minus 8/9, which would leave me with 7/9. That was saying ninths a lot. All right, and then I have either 1 take away 3, which means I need to borrow, or I have 11 take away 3, which is just 8. So this problem right here is 8 and 7/9 as my final answer. No picture was necessary, and 7 is a prime number. There's no factors besides 1 and 7, so I don't have to simplify it. So this one is already done. All right, let's give it a shot, and we'll try out just one more of these for an example. So I'm doing 4 and 2/5 minus 2 and 7/10. All right, so let's start that out. I have 4 and I have 2/5. Now I do know some people that I've seen in the past who, before they even write this out, one of the things they like to do is find the common denominator up here because they know they're going to have to. That keeps you or alleviates you from having to do it here once you've already have it written out. So I kind of like that idea, but I know for some of you, you like to get it set up first and then you work on it from that point. All right, so if that's the case, I've got 2/5. I need to turn them into tenths. I need to multiply 5 by 2 to get there, so I'm doing times 2 over 2. So I have 4/10 as my equivalent fraction. So this is now 4/10. So I've got 4 and 4/10 minus 2 and 7/10. Okay, this time I'm not going to rewrite it because I know most of you don't anyway. And so we'll just take a look and see if it's easy enough to do without realigning it. All right, Now, question is, we work our way from the right to the left. Can I do each of these steps? Can I do 4/10 minus 7/10? No, you can't take away 7/10 if all you had is 4/10. So we borrow like we would always do. If you don't have enough in this place value, you go to the next one over and you borrow from it. Okay, so borrowing, this becomes 3. Okay, now last time when we broke this apart, we turned it into ninths. Okay, we turned it into 9/9. The reason we did it that time was because we needed ninths. This time I'm trying to take away tenths because I don't have enough of them. So I am actually turning this one that we just borrowed into 10/10, and I'm adding it on here. So those 10/10 plus the 4/10 makes this now 14/10. So 14/10 minus 7/10 is 7/10 still, because 14 minus 7 is 7. And then I have 3 take away 2 is 1. So I end up with 1 and 7/10. All right. As you go ahead and you do your subtraction today, I would highly recommend, if you are doing it equation based, just number based, write them on top of each other. It's much easier than trying to line them up going horizontally. And then be very careful when you borrow. This is the only time when you borrow that you're actually going to put 10 there, when it is actually tenths. If it's thirds or fourths or fifths or sixths, then you have to change the one that you borrow into thirds or fourths or fifths or sixths, whatever it is that you actually are subtracting. So just be careful and take your time with it, and everything should come out correct. Thank you.